Hi, today in this video I'm going to be etching a circuit board. It's quite simple to do. Sometimes you need to do it, especially if you're working with very fine pitch stuff. I try to do it with a breadboard with dead bug, but I'm not always the best at that. Okay, in order to etch your own circuit board, first of all, you need obviously some blank copper clad board. Now, in the past I've done it where I've taken an old board. Do I have any? Oh, say like this one here. It's got a large power planes on it. Basically, if you cut the board, that bit of board out, and scrape off the photoresist on it, or solder mask, whatever you call it, you can make the copper go bare. So you'll end up with a small piece of this. This is single-sided, because I intend to only use single-sided for this project. Okay, then what you need to do is you need to obviously find a way of masking the acid from the circuit board. Now we're going to use the toner transfer method. Now I'm not going to show you that bit of actually making the design, because you should be capable of doing that if you're ready to make a circuit board. Now what you need is a piece of special paper that's designed for toner transfer. If you look on eBay, you'll find it really cheap, like 10 cents a sheet. Anyway, it's usually yellow. I bought a pack of 10 for like $5. Anyway, what I've done is I've printed the like a breakout pad. I also put some other stuff on there using my laser printer. You know, you're going to make sure you print on the shiny side. There's shiny and there's dull. It needs to be on the shiny side. A good friend of mine has had great success in using a Christmas wrapping paper to do the same thing. I think he said he printed on the picture side that was shiny, and that worked well. So that's the first step. The second step is you need a clothes iron, which I have around in the lab somewhere. I have to find it, but I'll have it again in a minute to show you. And then you need your acid. Now, if you can splash out and buy some ferric chloride, but that's expensive and messy. For me, it's not as readily available. There's not that many electronic supplies where I am. So I use a nice little combination. I use acetic acid, 5%, which is white vinegar, mixed with the same quantity of 3% hydrogen peroxide. You want to mix them as a 1-to-1 ratio, and from the instructions I've been working off, you add a little sprinkle of table salt. I'm not really sure if that is that very good. I got to speak to some chemistry people about it to see if I can improve this recipe at all. Now, I did email with Professor Polyakov he's on periodic video of elements, and he's also in the University of Nottingham in the UK, and he said it isn't really his field, that kind of thing, but he said he thinks the salt's the problem. So unfortunately, I'm not gonna deviate from my recipe until I know better. But if I do find out better, I'll let everyone know. So the first thing to do is for me to sand off the oxide layer on here to get a nice finish on it. Now, I don't want it smooth, I'd like it slightly rough so the toner will stick to it. Now, the idea being is toner is actually plastic powder melted onto the surface of the paper here, and if you heat it up from behind it will stick to something else again. And this type of paper is not as easy to stick to as the surface of the copper board would be, which is the idea of why I'm using this special paper. So you should get more or less all of it transferring over. Now this is for the top layer. Do note that I mirror imaged it, so it will be the right way up when I transfer it. Most circuit board software you represent the bottom layer. It already has mirror image when you print it, so you don't need to mirror that one. But this is the top layer. So okay, so without further ado, let's get it all started. And do note that I strongly recommend you wear glasses when you play with these chemicals. Sure, the household chemicals, but either of them in the eye is not a good idea. Okay, I'll see you in a bit. Right, now what we got here is my my setup. I'm just waiting for the iron to heat up. Now I've got the board. I got the toner side face down onto the copper. So that the irons are heat, and I buffed up the surface. Now what it is, I took a couple of notches out of the paper and put a bit of tape on to hold it in place. It's important that it does not shift while you're doing it, otherwise it'll ruin the whole thing. Oop. Come on, get to focus. Right. Now, and what I like to do is I like to sandwich it between two pieces of paper, and I always do it on a piece of wood to protect the surface. This has two reasons: A, to protect the iron from the board and the board from the iron, and to protect the wood from the board and the board from the wood. And another thing we need is we're going to need water to quench it once it's done. Okay, I got water in there now. That also helps remove the paper when it's done. So, irons at heat. Let's make sure the cable is out of the way. Now, what I like to do is I like to just, to begin with, set the iron on. Let the heat soak in to begin with. Now, this is my my bubbler. I'm going to explain to that in a bit while that's quenching, when I've done this bit. And then I'm going to mix the chemicals also while it's quenching. So, okay. Now, it's important not to move it too much when you do this. Like, you push down, lift it, shift it, and push down again, but do not slide the iron, because you'll smear the toner, because the toner should be molten at this point, and if you smear it, then it doesn't do very good, and also your footprints may not be true anymore. Just to note, the iron is set at the highest possible temperature I can get it, with no steam. There's no water in this iron at all. That is important, because it will ruin the whole thing. Now, usually they say about 2 to 5 minutes of heat. No. But you just need to experiment and find what's best for you. So I'm just gonna go try different parts of the iron on it, because obviously the iron's got like holes and ridges and stuff. You just want to make sure you saturate as much as you can and as evenly as you can. Believe me, this isn't even the boring bit yet. Okay, I'll come back when I'm ready to quench it. Okay, I'm about ready to quench it now. what I do is so I'll open this up. It's a bit sticky because there's tape on it and it's melting. Just stick it in the water. And you leave that for a good few minutes. So let's unplug the iron. Eek. For the plug not to be in the water. Okay. Next, we're gonna start mixing the water, the acid. Right. What we have here is a basically a dollar store container with a lid, a piece of fish tank tubing. I got from PetSmart, and just a fish tank bubbler, also from PetSmart. Okay, so in order to make these, basically we're going to do equal quantities of peroxide. We don't need to do too much. Just going to make sure we do it even. I reckon. Do 250. Right. This is hydrogen peroxide. I'm going to stick that in my bubbler. And put the lid on that. Don't worry, I've got my safety glasses on. Vinegar. I know this isn't a level surface, but I've got the jug in the same place and I'm doing it to the same point, so the measurement might not be accurate, but the quantity should be the same. Okay, now let's add that to the peroxide. Remember, acid to water, and hydrogen peroxide is almost water, H2O2. I'm going to put that out of the way, and then basically just add a bit of salt. Yeah, just a pinch of salt in there. Okay, now I'm going to put the lid on for now. And we're going to plug the bubble in. Nope. Bloody American plugs. Right. Should take a minute for the air to get through. Now you may be able to see a little bubbling coming out of there. Maybe if we go to the top you'll see it better. There we go. Seems to be in a bit of a blockage in the pipe, but seems to be doing much better now. Okay, now let's take a look at this circuit board. Now it's been drenched. Nice and clear, that's a good sign. Okay, so we'll switch to the camera stand. That'll make it easier to see me open it up. Right. The idea is you should gently peel it off. Just needs a little longer to sit in the water. Okay, now we're ready to get it in the acid. I've cleaned it off, unfortunately. The light's not very good here. I stuck it to a stick, and I'm going to stick it in the acid now. It's going to take about an hour for it to etch the whole thing in. Yeah. Just double check. Okay. Yeah, the whole thing's in. Looks like it isn't, but it is. Okay, and I'm going to try and time lapse this. Right, I've taken out the acid and I washed it, and here's the finished product. Now I'm going to hold it up against the light. Hopefully I don't dazzle the camera, but hey, as you can see, oops, I'm going to drop it. I'm going to hold it up again. Right. The one on the left is a good one. There's a couple of bits that need to be repaired on it. So there's obviously a break right here, possibly some here. It looks pretty good. Now this one didn't come out well. It actually looked like it smudged during the heating process. I might be able to clean this one up, but you know, I'm not going to be counting on it. But yeah, that's basically it. All you do is you can leave the toner on if you want. When you go to solder, it'll melt it away, and it'll act as a you know, stop it oxidizing. And you can also use this technique to make silkscreen if you want, but you got to keep in mind that when you're soldering the board, it'll some of it will melt away. And but yeah. But anyway, yeah, that's the tutorial on how to etch a circuit board using household chemicals. And if you like it, please give me a thumbs up, and any comments or questions, please feel free to add them below. Okay, thanks, goodbye.